In this lesson of differentiations, part 2, we'll be looking at the notation for differentiation, differentiation of monomials, the differentiation of polynomials, and the composite functions technique of differentiation. Now, from our examples using gradient function, first principle, to find the derivative of functions, we found out that for y is equal to 3x squared, the y, the x is equal to 6x. Also, for y is equal to x cubed, the y, the x is equal to 3x squared. Then we differentiated y is equal to 2 root x, and our dy dx gave us 1 over root x. When you look at this trend, we could derive a notation for differentiation. This notation is y is equal to a x raised to power n. So it means that our dy dx is equal to n a x raised to power n minus 1. This is our notation for differentiation. So we can use this particular notation to differentiate monomials, to differentiate terms in a polynomial. Let us use this in the differentiation of monomials. Here we have 3 differentiations to do. The first one says find the derivative of y is equal to 7x raised to power 8. Our y is equal to 7x raised to the power 8. But you recall that if our y is equal to a x raised to power n, then our dy dx will give us n a x raised to power n minus 1. So in this particular case, what is our a? Our a is equal to 7. Our n is equal to 8. So it follows that dy dx will give us 8 into 7 into x raised by 8 minus 1. This is equal to 56 x raised by 7. This is our answer. For number 2, our y is equal to 5 root x, or written as 5x raised to power half. And here our a is equal to 5 and our n is equal to half. So dy dx, which is equal to na x raised to power n minus 1, will become half into 5 into x raised to power half minus 1. So dy dx will give us 5 over 2 x raised to power minus half, and this is something as 5 over 2 root x. The third one says y is equal to 2 over x. We can write this as 2 x raised to power minus 1. So our a is equal to 2, our n is equal to minus 1, and we know that our dy dx is n a x raised to power n minus 1. So our dy dx will give us minus 1 into 2 into x minus 1 minus 1. So this will give us minus 2 x raised by minus 2, which is same thing as minus 2 over x raised by 2. This is our answer. It is important for us to understand this notation. Now it is not left for us now to apply this notation in the differentiation of polynomial. So the next thing we're going to do is differentiation of polynomials. So let us apply our differentiation of each term in this polynomial. We have our y is equal to 2x squared minus 5x plus 3. So we'll differentiate 2x squared, we'll differentiate minus 5x, and we'll differentiate 3. So our dy dx is equal to, using the notation, 2x squared will become 4x, minus 5x will become minus 5, and 3 will become 0. So our differentiation dy dx is equal to 4x minus 5. Let us do another example so we can establish this aspect of differentiation of polynomials. So here we have y is equal to 2x cubed minus x plus 1 all over x squared. It is good for us to split this particular fraction into its partial fractions. This will give us 2x cubed over x squared minus x over x squared plus 1 over x squared. So this will become 2x minus 1 over x plus 1 over x squared. When we write this on a particular line, this will give us 2x minus x raised by minus 1 plus x raised by minus 2. So upon differentiation, dy dx, applying the differentiation of monomials in this particular polynomial, will give us 2 minus 1 into x minus 1 minus 1 plus minus 2 into x minus 2 minus 1. So this is equal to 2 plus x raised by minus 2 minus 2 x raised by minus 3. This will give us 2 plus 1 over x raised by 2 minus 2 over x raised to the power 3. This is our answer. Now, differentiation is important, but we must have different methods, different ways to do our differentiation. It's not always easy to differentiate each term in a polynomial. For instance, we could have functions like this. Y is equal to 3x squared plus 2 all raised to the power 7. You know, to differentiate such function, you will need to expand and start differentiating each monomial in the polynomial. That is, to start differentiating each term, but that will look so ambiguous. So we have what we call the composite function. Let me just give you a summary of what the composite function looks like. If we have a general function y is equal to a into bx raised to the power c plus d all raised to the power m, where a, b, c, and d are constants. Both x and y are the only variables. What this means is that we are only differentiating x and y. To differentiate this, we are going to have the y, the x. This will give us, you take note of the powers involved in this differentiation, this and this. So when we start differentiating, we multiply the whole first with m into a, which is the constant before the bracket, into, we bring out the b x raised to power c, into b c x raised to the power c minus 1, into, we bring out everything now under this bracket. That will give us b x raised to power c plus d all raised to the power m minus 1. Actually, this is the idea of differentiation using the composite function. But there is a simpler way, though we are still using this formula to differentiate. Let us look at the following examples. Y is equal to 3x minus 1 raised to the power 9. We say let u be equal to 3x minus 1. So what this means is that we can differentiate u with respect to x. That is, the u, the x will become 3. And if our u is equal to 3x minus 1, it variably means that our y is equal to u, which is 3x minus 1 raised to the power 9. This also means that we can differentiate y with respect to u. This is equal to 9u raised to the power 8. But we are differentiating the function y with respect to x. So the differentiation dy dx, which we are supposed to get, will give us dy du times du dx. You notice that our du will strike out and we'll still get back, will result back to the dy dx. This is the same thing as, what's our dy du? Our dy du is 9u raised to the power 8 times our du dx is 3. So this will give us 27 u raised to the power 8. Recall that our u is equal to 3x minus 1. So our dy dx will give us 27 into 3x minus 1 raised to the power 8. This is our answer. We can solve this using the formula I gave before. We say y is equal to 3x minus 1 all raised to the power 9. And I said that if this is a function like this, the y dx will give us m into a into b c x c minus 1 all into b c b x raised to the power c plus d all raised to the power m. Now, how do we bring this in? We say that is if our y is equal to a into b x raised to the power c plus d all raised to the power m. So let us start comparing. What is our a here? Our a is the coefficient before the bracket, which is 1. Our b is the coefficient of x within the bracket, which is 3. Our c is the power of x within the bracket, which is 1. Our d is the constant minus 1, and our m is equal to 9. So let us substitute these values in our differentiation. dy dx will give us 9 into 1 into our b is 3, our c is 1, x raised to the power 1 minus 1 into 3x raised to the power 1 minus 1 all raised to the power 9 minus 1. Please, this is m minus 1. So this will give us 9 into 3. 1 minus 1 will give you 0. X raised to the power 0 is 1 times 1 into 3x minus 1 all raised to the power 8. So the y, the x is equal to 27 into 3x minus 1 raised to the power 8. You see, this is the same answer we got in the previous solution. Let us do another example and you'll see what I mean by composite function. So let us do an example. Here we have y is equal to 1 all over 3x plus 4 squared. You know, this can be written as this: y is equal to 3x plus 4 raised to the power minus 2. So we said that if our y is equal to a into b x raised to the power c plus d all raised to the power m, then our dy dx will give us m into a into b c x raised to the power c minus 1 into b x raised to the power c plus d into m minus 1. So we start comparing values. A here is equal to 1, b is equal to 3, c is equal to 1, d is equal to 4, and m is equal to minus 2. So our dy dx will give us minus 2 into 1 into 3 times 1, which is 3, x raised to the power 1 minus 1 all into 3x raised to the power 1 plus 4 raised to the power minus 2 minus 1. So this will give us minus 2 times 1 times 3 will give us minus 6. X raised to the power 0 will give us 1. Minus 6 times 1 is minus 6 into 3x plus 4 raised to the power minus 3. So we leave our answer the way the question was asked. The y, the x will give us minus 6 all over 3x plus 4 raised to the power 3. This is our answer. Let us do one more example to establish the idea. Okay, this is differentiate the function y is equal to 1 over the root of all of 3x minus 4. We have y is equal to 1 over the square root of all of 3x minus 4. We can rewrite this as 1 over open bracket 3x minus 4 all raised to the power 2, and this can also still be written as 3x minus 4 raised to the power minus 1 over 2. So the y, the x will give us minus 1 over 2 into, that is our m, into 1, which is our a, into 3 times 1 times x raised to the power 0, which is our bcx, into 3x minus 4 all raised to the power minus 1 over 2 minus 1. So this will give us minus 3 over 2 into 3x minus 4 minus half minus 1 will give us minus 3 over 2. We could leave our answer like this, but it's better we put it the way the question was given. So this will give us minus 3 all over 2 into 3x minus 4 raised to the power 3 over 2, and this will give us minus 3 all over 2 the square root of open bracket 3x minus 4 all raised to the power 3.